In this recording, we're going to review how to solve linear systems of equations by substitution. This was something you would have learned back in Algebra 1, but probably forgot, so we're going to review it here so that we can build on that and start solving linear quadratic systems. So, first off, what you want to try to establish is one of these equations with either x isolated or the y isolated. So look them over. Hopefully you identify that the bottom equation would be easier for me to get y by itself, because all I'd have to do is add 13. So let's rewrite that as y equals 5x plus 13. From there, we're going to take this expression that y is equal to, and we're going to make a substitution in place of y. If these two sides are equal, I can substitute, just like 4 quarters and $1. They're equal in value, I can make a trade, I can make a substitution. So in place of this y, I can make that substitution. So we're going to write out the top equation, but in place of our y, we're going to substitute what it's equal to. I'm just showing colors here just to make it explicit. I'm putting in place of the y, I'm substituting in something that's equal to y. Now hopefully you can take it from there. Why don't you get as far as you can with this? Play the recording when you solve for x. Okay, so hopefully you took care of that. You distributed the -4. Now remind yourself you're distributing a -4. Now that I've solved for x, it's going to be pretty simple for me to solve for y. I just need to look at either of those original equations and decide which one's going to be easier to work with. So I'm going to look at that bottom equation because it already just has y and not a coefficient in front. I'm going to write that out, but in place of the x, I'm going to write its value. I'm going to write 5 times -2, and now I just need to do a substitution. I've got y minus 13 equals -10, and so y is equal to 3. Now I've got my answer, and I just need to check it by graphing. So I'd like you to make a graph of those two lines. It's going to be easier said than done. First off, we have to get the top equation to be in y equals form. So let's solve it for y. Okay, so now that we've got both our equations solved for x, we had our original bottom equation, which we had already solved. We've gotten in the slope and intercept form. And then we have our top equation, which we solved. We have our slope and our intercept. So we're just going to make those graphs. I have to approximate a little bit where the y-intercept would be, because it's a little off the grid, but I can just say that's 10, 11, 12, 13, approximately. And then we can proceed to graph the slope and y-intercept of that graph. So that has a graph has a slope of 5. This has a y-intercept of 13. Go ahead and make that line. This has a y-intercept of 9/2 and a slope of 3/4. And now for the line that has a slope of 3/4 and a y-intercept of 4.5, which is 9/2. So plot that and just go up 3/4. 1, 2, 3, and then over 4. And then do the same thing going down. 1, 2, 3, and over 4. Of course, you do want to label the functions, and I'll use the original labels. And the final piece is, does it check? Well, yep. It looks like the coordinates of -2, 3 are the intersection point. Check. Thanks for watching.